Phase shift is a horizontal translation of a sine or cosine graph. Basically, it moves it left or right. Horizontal, left and right. All right, the graph. So if we have sine or cosine of, in parentheses, x plus c, that is a phase shift by negative c units. Remember when we talked about transformations, and this was a very tough concept to kind of grasp because there's so many, but anything that happens inside, anything that's horizontal, left or right, it's opposite. So if you see a plus 2, that technically means it moves left 2. We say a horizontal translation by negative 2 units or whatever it is, okay? If it's written out in words. So that's true for both sine and cosine. So the function that we're looking at, f of x equals a sine of b, and then in parentheses x plus c plus d. So everything, I just added that plus c. Now the thing is, if there's a number in front of the x, and we'll see some examples like this, you have to factor out the b value. Like, see here in number 1, see how that 4 is factored out? But like here in number 3, it's not. For this to work, for you to do it correctly, you have to have, like, if there's a number in front of the x, so if you have a b value other than 1, it has to be factored out. Okay. All right, so number 1, we're not going to graph or anything yet. We're going to identify all the parts. So we have everything that we had yesterday, but plus a phase shift. So what is my amplitude? 13. Remember, 13, the amplitude is the distance from the midline up or from the midline down. All right, so that's A. My period is 2 pi over B, which means it's 2 pi over 4. And if I simplify that, it becomes what? 1/2 pi, or pi over 2 is how you'll see it. Okay. Now the phase shift, that's your C. So I would say it's a phase shift of negative pi over 11. It's going to move left pi over 11 units. Which hopefully if you were graphing this, you would not have to graph that, because that's, hopefully it's like pi over 4 or pi over 2 or something. And then my midline is what? -7. Good. So the only thing we're changing is, from what we've done, is add in the phase shift. Now number 2, if you'll look, instead of using x, it uses theta. That's common. You could see either one. But this is theta over 2, which is really 1/2 theta, right? If you divide by 2, it's the same as having 1/2. I'm going to rewrite that in case it might help you. 1/2 theta minus pi over 5. Those are equivalent, the same thing. But still, I have to like factor out the 1/2 because we need theta all by itself. So if I factor out the 1/2 here, I have to take out 1/2 there. What's that going to make that second fraction? Basically, we're dividing it by 1/2. Kind of. Dividing by 1/2 is the same as multiplying by 2. So this would really be 2 pi over 5. That's ugly. And if you think about it backwards, if I wanted to distribute this back in, if I multiply 1/2 times 2/5, making the same as multiply by 2. So now we can identify all pieces. So the amplitude is 2. The period is 2 pi over 1/2, 2 pi over b, which is what? 4 pi. Dividing by 1/2 is the same as multiplying by 2. So 4 pi. The phase shift, I'm going to abbreviate that, is positive 2 pi over 5. It's going to go right. So if in your equation it's a minus, your phase shift is the opposite. And then my midline is what? -5. Number 3, I have that 3 in front of the x, so we have to factor that out. I have pi over 6, and I divide that by 3. It's going to be pi over 18. So 1/6 divided by 3 change flip. It's the same thing as multiplying by 1/3. Same thing as like if it was 1/6 divided by 1/3, that would be the same thing as multiplying by 3. So this would be pi over 18. What is the amplitude? 6. Good. What is the period? 2 pi over 3. Phase shift? Negative pi over 18. It's going to move left. And the midline is 11. Now when it comes to graphing these, we're actually going to treat it as if the phase shift is not there, and we're really lightly going to kind of sketch it in. So if you are not working with a pencil now, you need to work with the pencil partly. Okay, so we're going to kind of graph the original one without the phase shift, and then we're going to scoot it over. I think that's the easiest way to do it. So what I'm going to do is like the first one that I do, the original one without the phase shift, I'm just going to go in and make like a little X where the points should be, and then we'll scoot it over. All right. So right now my phase shift is negative pi over 4. So ultimately we're going to move left, but we're going to save that until the very end. My amplitude is 2. My period is 2 pi over 1. And my midline is 0. So midline is 0. Okay. So this is if we were just graphing 2 sine of x. So I'm going to use my pencil. All right. Remember sine looks like that. So my starting, my ending, my halfway is all on the midline. So I'm going to put a little x here, a little x here, and then halfway. And then halfway between these two, I would go up 2, my amplitude. Halfway between these two, down 2. And then I'm going to do the same thing over here. And if you want to lightly sketch it in, you can. But I would do it real light. Oops. Any questions on how I got this original one? Alright, we're going to move left pi over 4. So look at your scale. How many blocks do you think pi over 4 is? 1 block. Because pi over 2 is 2 blocks. Pi over 4 is half of that. So pi over 4 is 1 block. So we're literally going to go to every x and we're going to count we're going to count to the left 1 block, and that's going to be our point. Any questions? All right. Question number 5. Notice how this one is 2 plus. You might want to rewrite it, or you might just want to make a note. Normally we see that number at the end, so make sure you note your midline is 2, your amplitude is not 2. I think it would be very easy to think, oh, that's your amplitude because it's right in front of sine. Well, it's not right in front of sine. The amplitude is what's multiplied right in front. This is added on. So be careful. So what is the amplitude? The amplitude is 1. The period is what? 2 pi over 2, which simplifies to pi. The midline is 2. And then my phase shift is negative pi over 4, which means this one is also going to ultimately move left. So there's my midline. So I'm going to use my pencil. The period, and this one is sine. So we're going to start here. My one period or my cycle ends at pi. Halfway between that is also on the midline. And then halfway is up 1. The other halfway is down 1. Real lightly, and you could even like go in and erase this because this truly is not your answer. This is just kind of our step into getting our final answer. So it is left pi over 4. Our scale is the same, so we know that's 1 block. So I'm going to move all of these left 1 block, and it is a lot, honestly. So it would be easy to make a mistake, so just be careful. Any questions? All right, number 6. Ooh, okay, first of all, I know that it's cosine, and I know that it's negative. So normally cosine would look like that. Can you even see that? It's like the U, almost like, kind of like a U, but because it's negative, it's going to look like that. So that means my starting and ending is going to be at a minimum. The halfway mark is going to be at a maximum. And then the little halves are going to be on the midline. So the amplitude is 4. The period is 2 pi over 1/2. Yuck. Which is what? 4 pi. So we saw one like this yesterday where my starting, remember my ending was like off over here off the paper, so we'll go through that one carefully again. My midline is -2, and my phase shift is pi over 2, which means it's going to go right. Okay. All right. So my starting and ending. Well, let me get my midline first. -2. Okay. My starting and ending, remember I said was going to be on a minimum at -4. And my ending would also be over here at -4. But that's off my graph. Halfway between those, which is going to be at 2 pi, is going to be 4 units up. And I said -4, that's 4 units below the midline, sorry. 1, 2, 3, 4 units. So up there. So this point is really that point. It's the bump up. Okay. Halfway between those is going to be on the midline. So this one is going up. It's like really stretched out. So if it continued, it would kind of go down here. So this one's going to go back up like this. So it would be right there. 1, 2, 3, 4. That one will be right there. So that's kind of what your graph would look like. Maybe I did a very bad job. Okay. So that's the original. That would just be if that minus pi over 2 wasn't there. Okay. But we're going to move everything right pi over 2. How many blocks is pi over 2? 2 blocks. Yeah. So I'm going to move everything right 2 blocks. It really is not great, but you're not going to have to graph these by hand. It's going to be like the multiple choice where you're given a graph and you've got options. And now that I've kind of done this, I think the best way to approach those, and we'll get to one of those, I would pick out one point and try to plug and chug to see and eliminate what you can. But then it might be that you just kind of graph each one separately and see which one works. We'll see. All right, number 7. All right. I can see right away that my 2 needs to be factored out. So I'm going to go ahead and do that. So I'm going to divide by 2. It's going to be x plus pi over 2. So we factored out. When you factor out a number, you're dividing by that number. That negative kind of makes this one upside down. So instead of having a max first and then a min, it's opposite. You have a min and then a max. Okay. So the amplitude is 2. My period is 2 pi over 2, which is pi. My midline is 1. What's my phase shift? Negative pi over 2. So it's going to be moving left. So start, end, halfway on midline. And this time I'm going to go down 2 first and then up 2. And I'm just going to keep that pattern going. Backwards. So this is without the phase shift. And then I'm going to move everything left pi over 2. And pi over 2, based on my scale, it will not always be 2 blocks. You have to look at your graph, your scale here to know. But I know from this, pi over 2 is 2 blocks. So everything's going to move left, 2. This one is kind of, because they overlap, it's kind of hard. Last one we're going to graph. So This would be cosine. Gonna have to factor out that 2. It's going to be x minus, if you're dividing by 2, it's the same thing as multiplying by 1/2. So it's going to be pi over 4. The amplitude is 1. The period is 2 pi over 2, which is pi. The midline is 0. The phase shift is pi over 4. So it's going to move right. And remember, cosine like this. So max, max, min, the midlines are in the middle. So period is pi. So starting and ending is pi. Max, max. Down here's my min. And then in the middle is the midline. And then I'm going to move everything right, pi over 4, which is 1 block. So let's look at a multiple choice. So, I don't know. There's could be a couple ways you approach this. Here's kind of what I'm thinking right now, what I would do. First off, I would pick a point. For example, this point is the point pi 2. So if I plug in pi for x, and my answer does not give me 2, I can throw out that answer choice. That might eliminate a couple of them for us. Okay. So if I plug in pi right here, that's going to be 3 cosine of pi minus 1. And here's where you're going to need your unit circle to know what cosine of pi is. Does anybody know what cosine of pi is? You're not expected, -1 actually, you're not expected to have all these memorized. Now you might memorize like the pi, this is times negative 1 minus 1. Negative 3 cosine pi of 0. Look on your unit circle. What is that? 1. Something else you could do to maybe eliminate is look at away. Pi plus 2. I could pick out another point, but chances are you would get a automatically assume the correct answer. Ones, because a lot of these might have overlapping points here. 3 sides minus 1, and then shift it left to graph this like we just did to see if it's truly that black line. And if it's not, then it's going to be D. So I can't truly automatically say, as long as there's a phase shift. If there's a phase shift, you can't say it's definitely sine or cosine just from looking at it. Okay. So this has an amplitude of 3, midline of negative 1, period of 2 pi. Okay, so I just wrote those notes down. If I was taking the AP exam, this is literally what I would write down. So I would say, all right, midline negative 1 right here. Put 3. In this scale, 1 block is pi over 2. So from what I drew, if I move left 1 block, is it going to overlap? It's not. Really, this one, to get my black line, it's really moving right pi over 2. So from what I drew, if I were to move left pi over 2 1 block, it's not going to overlap. Had this been a minus, this would have been the right answer. Okay, so it's not C. So if you know for sure you're right about this, you can go ahead and click D. But if you want, y'all need to bring, maybe I'll buy them for you. You know those little clicker erasers? I'm going to get you some of those for the AP exam. So this other one has a midline of -1. Okay. This one has the -3. 1, 2, 3. I can already see from this, if I take my line and go left 1 block, I'm going to be overlapping. So it is D. By doing this, what I did in pink beforehand, that's just saving you the time of having to graph all of them, I would think. And you could find enough points and figure it out, but that would take you a long time. So, a few ways you can go about it. Alright, so this is the same thing. So I want you to do number 7. Okay, so this would be 2 cosine. That's going to be 0. That's going to be 0 plus 1. 3. Oop, look, not -1, so it's not that one. I can try pi over 4 here again. That's going to make this 0. Oops. Plus 1. Sine of 0 is 0. That's going to give me 1. So this possibly, I'm not going to say for sure that C is it, but I know that it could be. If I can eliminate D, then I don't have to do any graphing. But let's say I try pi here. Zero. Look, when I plug in pi, I get the exact same thing. Wait. But it needed to be -1, right? So if I plug in pi, I need to get -1 as an answer, because the point pi -1 is pi -1. So this would give me +1. So this one I eliminated just that way. When I did number 6, which I probably didn't pick out the best points. When I did number 6, I got the same answer, so I had to graph it. You could pick out other points and eliminate without graphing. It's kind of, if you want to risk, just depends on how much time you want to spend on it. But try to get it right. Like, if you know that you can do this and you can get this one right, take a little bit of extra time and sacrifice time on one that you just don't really remember. That kind of strategy is same true for ACT. But, okay. We'll do number 8. So I will not see you tomorrow. How many of you still need to do test corrections on your last test? Well, how many seniors?
I still need to do the test.
You haven't done the test yet.
No, me either.
Okay. Yeah, we need to get you to do that. Are you in the library tomorrow?